Second unit, insertion sort. Yeah. So that first unit is used as a small introduction. Yeah. Because in this one, we need to use that decrease by constant, decrease by 1 idea. Yeah. Reduce the size, or divide and conquer, but size reduced by 1. Yeah. Yeah. Why? So let's look at that. Revisit. Yeah. 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 A different view, different algorithm for the same problem. Okay. Yeah. Strategy this time. Yeah. Start with a simple case. Yeah. See? This is the most frequently used strategy so far in our class, right? Yeah. Yeah. Simple case. Yeah. Then grow the data size gradually, one by one. Yeah. So here you can see, in general, this method, not very fancy. Okay? Not very fancy. Anyone can understand easily. No. But to solve this problem, to make that happen, you need to do a lot of analysis to make that happen. Because it's not that obvious, right? Not that obvious. No. All right. Let's see. Every time we increase the size by 1. Okay, so let's do it. Okay, all right. Connect two other JSON cases, analysis. So let's do this, working on the problem size. Let's draw a diagram. Try to get an idea. Okay. When we start, the array size is 1. Do nothing, right? 1. It is sorted. It is sorted. So do nothing. Okay. So we cannot see anything from this. But that's our starting point. We start from the problem of the smallest size with some data. Okay. Yeah. Then the next problem size, 2 elements. So let's compare. How do we get this array sorted from the first element, but we need, based on our intuition, we need to have a new element added to the current array to get it sorted. That's our intuition. Okay? Yeah. So how do we do that? You need to do one comparison, right? One comparison, you can get it sorted. Yeah? That's simple. Yeah, one comparison. But you cannot do no comparison, right? You have to do one comparison. Okay? All right. So when you add a new element to the current array, you do one comparison, you can get the problem with larger size, the size 1 more than the previous one, solved. Yeah? All right. Make it sorted. Okay? All right. So let's look at another one. Yeah? Because only this one case study still not enough. We need to look at another case study. Okay? Yeah. Now we have a new element, A2. How do we get a new problem with 3 elements sorted? Yeah. Best case and the worst case, right? What is the best case? One comparison. Huh? You compare A2 with A1, it's greater than A1. That's the best case. The worst case, smaller than A1, so then you need to compare with A0. Okay? So the best case and the worst case. Okay? Now I want to ask you one question. For this particular problem, compare A2 to get whole array sorted. What is the average case efficiency? How many comparisons do you need for the average case efficiency? Average case. Best case 1, worst case 2. Okay. Can you get an average case? Best case 1, worst case 2, somewhere between 1 and 2. What that number should be. Is it 1.5? 1 plus 2 divided by 5? Be careful. Be careful. Because think about the probability, the best case happen and the probability of the worst case happen, are they the same? The two probabilities. Compare the probabilities. If the probabilities are different, when you take the average, you need to take the weighted average. Weighted average. Think about the worst case happens more likely, or the best case happens more likely. Consider that. Okay? A2 could be anywhere, right? A2 could be anywhere. So let me draw a diagram. All right, let me draw a diagram. E0, A1 already sorted. Okay. Now, suppose A2 different from A0, A1. We assume distinct elements. All right. Now, there are 3 possible places you can put A2. 1, 2, 3 here, right? For A2. 3 possible cases. Okay? In those 3 cases, which one corresponds to the best case? Which one corresponds to the worst case? Yeah. The best case, only 1 of the 3. The worst case, 2 of the 3. Can you say they have the equal probability? Okay? Yeah. So that's why the worst case happens twice as many. Twice as many as the best case. Okay? All right. So if you want to calculate the average case efficiency, it should be 2 worst case, each one 2, right? 1 best case 1 divided by 3. That's your answer. Okay? Yeah. Worst case 2, but it happens twice. Okay? Best case 1 happens once. Okay? The average of all the possibilities, you get this. Okay? So that's how do you calculate the average case. Yeah. All right. All right. Okay. Yeah. So now we try to get some more information. All right. All right. Now look at the action we are doing here. Yeah. Currently we have 1 sorted array. Yeah, this is a sorted array. Okay? And we have a new element comes in, and we want to put it in place. Okay? Put it in place. Yeah. So that whole action, if we use our imagination, use our intuition, yeah, Yes, we can say what we're doing. Basically, we do insertion. That is an insertion operation. Okay? So we insert this element somewhere. Yeah, we don't know where, but we first, if we can find the right place, we will insert it in that place. So it is an insertion action. So we want to discuss, we want to study this special operation, insertion operation. What is the property of insertion operation? Can we use this insertion operation to sort the array? Yeah. So that's our question. Okay? All right. Insert an element in a sorted array at the right position. Okay? So here you can see this whole operation. You need to do basically two things. First, find the right position. Second, insertion. Second, make room, right? Make room for the new element. Okay? Then put the new element in place. Okay? So that's the basic procedure. Okay? All right. Yeah. Very simple. Yeah. But we need to study that insertion operation, our key operation. Okay? All right. Let's look